All right, we're going to get into the majority of the factoring problems that we will see. The first section, or the next section that we're going to look at, is factoring the trinomials whose leading coefficient is 1, or just x squared plus bx plus c. In order to do this, you do need to know how to find all factors for a given number, understand your rules for operations with signed numbers, and understand how to multiply binomials. Let's review some multiplication before we talk about factoring. If we look at the first example, let's go ahead and FOIL. We get x squared plus 5x. Insides we get plus 6x. And last we get plus 30. If we combine now, we get x squared plus 11x plus 30. Okay, let's look at another one. We're going to change it up a little bit by changing the signs. So first we get x squared. Outsides we get minus 5x. Insides we get minus 6x. Lasts we get plus 30 again. If we combine our like terms now, we are left with x squared minus 11x plus 30. Next one, same thing, we're going to change up some signs. First we get x squared. Outsides we get minus 5x. Insides we get plus 6x. Lasts we get minus 30. Combining our like terms gives us x squared plus x minus 30. Last one. First we get x squared. Outsides we get plus 5x. Insides we get minus 6x. And lasts we get minus 30. When we combine our like terms, we have x squared minus x minus 30. So now let's look at some things that we want to notice. Notice that our binomials are the same except for the signs. What do you notice about the results? If the signs are the same, the last digit of the trinomial will be positive because we're multiplying positive times a positive or negative times a negative. So when we go backwards now, we have if this is positive, then we know the signs are the same. If the signs are different, the last digit of the trinomial will be negative because we are multiplying a positive times a negative or a negative times a positive, which will always result in a negative answer. If you look at the numbers now, the 6 and 5, the lasts, will always multiply to the last term of the polynomial. No matter what, 6 and 5, our last is going to be 30 no matter what our signs are. Now, we already talked about whether the signs are the same or whether they are different, but how does it affect the middle number? Because the middle number is one of the most important ones here. If the signs are the same, the lasts will add to the middle number. Notice that on the first two examples, we got 11 on both of them. One of them was positive, one of them was negative. But since we are combining numbers with same signs, we get add, keep the sign. If the signs are different, like the last two, we will subtract to the middle number. Remember, numbers with different signs, you subtract, keep the sign of the larger number. So we get -5 and +6, subtract, keep the larger sign. 5x and -6, subtract, keep the larger sign. Let's now reverse the rules. If the last digit of the trinomial is positive, the signs are the same. They are the same as the middle number. Pick numbers that multiply to the last digit and add to the middle term. If the last digit of the trinomial is negative, the signs are different. The larger number has the same sign as the middle term. Pick numbers that multiply to the last digit and subtract to the middle term. All right, so let's start with a very basic example. We have x squared plus 6x plus 8. So a couple things to remember. We are multiplying to a positive 8. In order to multiply to a positive 8, we have same signs. And since our numbers are same signs and we're combining to a positive 6, both are positive. So the first thing I'm going to do is write my two sets of parentheses. X squared, that's going to be x and x, and as I mentioned, our signs are both positive. Now from here, we want to talk about the numbers. So I want to start by looking at the 8. I want things that multiply to 8. So what are all the things that multiply to 8? Well, you have 1 and 8, and you have 2 and 4. Now recall that since we're talking same signs, if the numbers have the same signs, then they have to add to 6. So which pair over here adds to 6? It's going to be the 2 and the 4. So we get 2 and 4. So now we can go ahead and, this is our answer, okay? But we can also go ahead and check it using FOIL. If we FOIL, we get x squared. For our first, our outsides, we get 4x. Insides, we get 2x. And lasts, we get 8. Does that give us positive 6? Yes. And so this does check out. This is the correct factoring. Let's look at another example here. Again, we're going to start with our signs. So I have that we are again multiplying to a positive 6. If you're multiplying to a positive, that means that they are same signs. But on this one, in order to get to a negative, both have to be negative. So if we write our factors out, my firsts are x and x. I get minus and minus. And now I want to know what multiplies to 6. We get 1 and 6, 2 and 3. Now, you do need to be careful because one of these subtracts to 5, the other one adds to 5, and we need to be sure that we know which one we're supposed to be working with. When you combine numbers with same signs, remember that you add and keep the sign. So the ones that we are going to want to go with is the 2 and the 3. So we get x minus 2 times x minus 3. If we go ahead and check this to make sure that it's correct, we get x times x is x squared. Outsides, we get minus 3x. Insides, we get minus 2x. And lasts, we get plus 6. This does give me negative 5x, and so my factoring is correct. This is the correct factoring. All right, let's look at a couple more examples. The next one, we have x squared plus 2x minus 35. I'm going to start with my signs again. This time, because it's negative 35, I know that my signs are different. Remember that we want to multiply to negative 35. The only way you can multiply to negative 35 is a positive and a negative. So I'm going to write out my two parentheses. My first, again, are x and x. And I'm just going to put my signs in. It doesn't matter where they go at this point, but we know that they are different. Okay, so now I want to know what multiplies to 35. Well, things that multiply to 35 are 1 and 35 and 5 and 7. Since we are talking different signs, remember that in order to combine numbers with different signs, we subtract, and our larger number is going to be positive. So, which pair subtracts to 2? That's the 5 and the 7. My 7, since it is larger, I want it to have the same sign as the middle term. So I'm going to put the 7 with the plus wherever the plus is, and I'm going to put the 5 with the minus wherever the minus is. So now if we go ahead and distribute, or FOIL, we get our x squared, outsides is negative 5x, insides is positive 7x, and lasts is minus 35. We combine our like terms and we get x squared plus 2x minus 35. So this is the correct factoring. Okay, a few more examples. For D, we have y squared minus 6y minus 27. So my factors, I'm going to start off with my first are y and y. I note here that in order to multiply to negative 27, I do need different signs. So I'm going to go ahead and put those in. Minus plus, again, it doesn't matter where you put your signs, okay, as long as they're different. Next thing I want to know is what multiplies to 27. So we have 1 and 27, 3 and 9. Remember that when we combine numbers with different signs, we're going to subtract and keep the sign of the larger number. Since we are keeping the negative sign, then I want to make my larger number negative. Subtracting to 6 is going to be the 3 and the 9. So I'm going to put my 9 with my minus sign, 3 with my plus sign. We FOIL. First, we get y squared. Outsides, we get 3y. Insides, we get minus 9y. And last, we get minus 27. Does this give me negative 6? Yes, it does. We subtract, we keep the sign of the larger number. It's negative, and so we are good. So the correct factoring of this is y minus 9, y plus 3. This is a special case. Note there are no numbers that multiply to 5 and subtract to 1. The only things that multiply to 5 is 1 and 5, and you can either add those to 6 or you can subtract them to 4. But nothing gives us 1. So there are no numbers that work. Thus, this cannot be factored. Not everything is factorable. So do you remember what we called a number that could not be factored? Think back to prime factorization. If it doesn't factor, if it's a number that doesn't factor, we call it a prime number. Well, this isn't a number, but this is prime. What we call this is a prime polynomial. Now, keep in mind that there is a difference between something cannot be factored and you can't factor something. So make sure that you exhaust all possible avenues, or that you know for a fact that it does not factor before you start writing down prime polynomial as an answer. I had a student one semester who she put prime down on every single problem on the exam, just hoping that she would get at least one of them right. So I will warn you that there will be maybe at most one prime polynomial, but that's it. Everything else should be factorable. Anyway, I digress. This example is known as a prime polynomial. The last example, well, this one has multiple variables in it. And don't let the multiple variables fool you or trick you into thinking it's harder than it is. Just like with the x's, we're going to do the same thing with the y's. So, for instance, my x's, I'm going to let those be my first. And my y's, I know each one of them is going to have a y. So now let's just look at the numbers. We have multiplying to a positive 3. If you are multiplying to a positive 3, you have same signs, and both are negative. The only thing that multiplies to 3 is 1 and 3, and does that combine to give us 4? Remember that if we are having same signs, we want to add and keep the sign. Since these do combine to 4, those are going to be the ones that I want. So you can either write x minus 1y, or just x minus y and x minus 3y. I'll leave this one to check on your own. So some quick things to note before we move forward. If the signs are the same, the placement of the numbers does not matter. But if the signs are different, you need to make sure that the correct sign is with the correct number. If you can see which numbers need to be used without writing all the possibilities, that is great. But just like when we solved linear equations, I recommend getting in the habit of writing them out now so that you are in the habit of doing it when we get to the next section. Always check your answer. There is no reason to get any of these wrong. When you check, do it on a separate sheet of paper where you can't see the original problem. If you get the wrong answer, determine how you can alter your answer to get the correct answer. Do you need to change the sign, rearrange numbers, etc.? You don't necessarily have to start from scratch. Finally, never erase anything that you have tried that didn't work. In math, we always want to have an eraser handy, but not in this chapter. One of the reasons is that you may get in the endless cycle of trying the same thing over and over again. Whereas if you have them all written out, then you know which ones not to try again. Go ahead and try the following problems on your own. Bring them, as well as any questions you have, to class. That is it for this section.